Hello everyone and welcome to the lecture on AWS AppConfig. So this lecture will contain all these topics. What is AWS AppConfig? Boost efficiency and speed up change releases with feature flags. AWS AppConfig, avoiding unintended changes with built-in safety features. Secure and scalable feature flag deployments with AWS AppConfig. Use cases and how AWS AppConfig works. So what is AWS AppConfig? AWS AppConfig is a powerful feature integrated within the AWS Systems Manager service, providing a centralized platform for application configuration management. AppConfig enables the use of feature flags, allowing developers to gradually release new capabilities to users. This approach minimizes risk and enables measuring the impact of changes before fully deploying to all users. With dynamic configurations, AppConfig empowers software developers to securely adjust application behavior in production environments without requiring full code deployments. This flexibility ensures smooth operations and minimizes downtime. By leveraging AWS AppConfig, organizations can significantly speed up their software release frequency. The ability to quickly deploy changes and configurations enhances agility and responsiveness to market demands. AppConfig improves application resiliency by providing a robust framework for managing configurations and feature rollouts. It helps ensure that applications remain stable and performant even in the face of changing environments and requirements. When emergent issues arise in production environments, AppConfig enables quick resolutions with ability to dynamically adjust configurations and feature flags. Teams can swiftly address problems and minimize their impact on end users. AppConfig allows for targeted operational tuning through the use of operational flags and dynamic configurations. Teams can update block list, allow list, throttling limits, logging verbosity, and other parameters to fine-tune application behavior and optimize performance in real time. So let's go get some more details about AppConfig, how to boost efficiency and speed up change releases with feature flags. Using feature flags with new capabilities speeds up the process of releasing changes to production environments, improving overall efficiency. Instead of relying on long-lived deployment branches that require complicated merges before a release, feature flags enable you to write software using trunk-based development, streamlining the development process. Feature flags enable you to safely roll out pre-release code in CI/CD pipeline that is hidden from users, minimizing the risk of introducing bugs or issues to the live environment. When you are ready to release the changes, you can simply update the feature flag without deploying new code, making the release process more efficient and less time consuming. After the launch is complete, the flag can still function as a block switch to disable a new feature or capability without the need to roll back the code deployment, providing an additional layer of control and flexibility. Okay, AWS AppConfig, how to avoid unintended changes with built-in safety features. So there is a feature within AppConfig called a validator. A validator ensures that your configuration data is syntactically and semantically correct before deploying the changes to production environments, helping to prevent application failures due to incorrect configurations. A deployment strategy enables you to slowly release changes to production environments over minutes or hours, which allows for controlled and safe rollout of new configurations. AWS AppConfig integrates with Amazon CloudWatch to monitor changes to your applications. If your application becomes unhealthy because of a bad configuration change and that change triggers an alarm in CloudWatch, AWS AppConfig automatically rolls back the change to minimize impact on your application users, providing a safety net against configuration related issues. Okay, now let's see about secure and scalable feature flag deployments with AWS AppConfig. AWS AppConfig integrates with AWS Identity and Access Management, AWS IAM, to provide fine-grained role-based access to the service, ensuring that only authorized users can access and manage feature flags. AWS AppConfig also integrates with AWS Key Management Service for encryption, adding an extra layer of security to protect sensitive data and feature flag configurations. AWS CloudTrail integration enables auditing of AWS AppConfig, which allows organizations to track and monitor all actions and changes made to feature flags for compliance and security purposes. Before being released to external customers, all AWS AppConfig safety controls were initially developed and validated internally, ensuring a robust and reliable system. Internal customers use AWS AppConfig at scale prior to its external release, providing real-world validation of service scalability and performance under heavy usage. Okay, let's summarize all the use cases. So, despite the fact that application configuration content can vary greatly from application to application, AWS AppConfig supports the following use cases, which we would have already got some idea, and this covers a broad spectrum of customer needs. So, first one is feature flags and toggles. So, you can safely release new capabilities to your customers in a controlled environment. You can instantly roll back changes if you experience a problem. Next use case is application tuning. So you can carefully introduce application changes while testing the impact of those changes with users in production environment. Third one is access allow list or block list, which is around access control. So you can control access to premium features or instantly block specific users without deploying new code. And lastly, we have centralized configuration storage. So you keep your configuration data organized and consistent across all of your workloads. You can use AppConfig to deploy configuration data stored in the AWS AppConfig hosted configuration store, AWS Secrets Manager, and Systems Manager Parameter Store or Amazon S3. So these are a couple of options to where to store your configuration secret data, or some other data also like S3 for some other types of data. So let's see how AWS AppConfig works. So step by step. So step 1. So before creating AWS AppConfig artifacts, you identify configuration data in your code that you want to dynamically manage using AWS AppConfig. So good examples include feature flags, allow block list, logging verbosity, service limits, and throttling rules. If your configuration data already exists in the cloud, you can take advantage of AWS AppConfig validation, deployment, and extension features to further streamline configuration data management. Next, you create an application namespace, which is an organizational construct like a folder. And to create a namespace, you create an AWS AppConfig artifact called an application. And application, as I talked about, is simply an organization construct like a folder within AppConfig. Third, you create environments which are logical groupings of targets. So for each AWS AppConfig application, you define one or more environment. An environment is a logical grouping of targets such as applications in beta or production environment, AWS Lambda functions or containers. You can also define environments for application subcomponents such as the web, mobile, and backend. Fourth, a configuration profile. So you create a configuration profile which includes a URI and profile type. A configuration profile includes, among other things, a URI that enables AWS AppConfig to locate your configuration data in its stored location, and a profile type. AWS AppConfig supports two configuration profile types. One is feature flags and second is freeform configurations. Feature flag configuration profiles store their data in the AWS AppConfig hosted configuration store, and the URI is simply hosted. For freeform configuration profiles, you can store your data in the AWS AppConfig hosted configuration store or any AWS service that integrates with AWS AppConfig. And step number 5, when you create a new deployment, you specify the following: an application ID, a configuration profile ID, a configuration version, an environment ID where you want to deploy the configuration data, and a deployment strategy ID that defines how fast you want changes to take effect. When you call the start deployment API action, AWS AppConfig retrieves the configuration data from the underlying data store, verifies the configuration data is syntactically and semantically correct, and caches a copy of the data called the deployed data, so it is ready to be retrieved by your application. And step number 6, you can configure AWS AppConfig agent as a local host and have the agent poll AWS AppConfig for configuration updates. The agent calls the start configuration session and get latest configuration API actions and caches your application data locally. To retrieve the data, your application makes an HTTP call to the localhost server. If AWS AppConfig agent is not supported for your use case, you can configure your application to poll AWS AppConfig for configuration updates by directly calling the start configuration session and get latest configuration API actions. Okay, so that's all. Thanks for watching.